All right, so yeah, the title of my talk is Designing for Tomorrow's Programming. Oh, hang on, I need to full screen this. Um, oh, okay, it is. Yeah, okay, great. So yeah, the title of this is Designing for Tomorrow's Programming Workflows. And the idea behind this is I notice as a programmer myself and a user of libraries and technologies, my workflows and patterns changing as new options are available to me. And so the question then becomes if, okay, the way that we program changes, how should we adapt the way that we're developing libraries and other resources for programmers, and how does this basically change the game for this? So in terms of genre of the talk, this is more of an editorial than something like a tutorial where I show you how to do a specific thing. So in other words, it's a bunch of me saying things. So I've tried to keep it also kind of short because it is before lunch, and in general these things there's only so much of somebody saying things that you can take in at once. So I wanted to keep it a bit more concise around the main points. So as a bit of background on me, I've been developing well, at least a lot of what I've been doing for the last 8 or 9 years is developing this library Spacey. It's a very popular library for natural language processing. So in other words, it helps you do core tasks like split up language into tokens, work on inflections of tokens so that you can say, all right, this verb has this sort of ending and this is its base form, this is a verb versus this is a noun, this is how these words relate to each other, this is the subject, this is the object, etc. And then also recognize entities and classify texts and things for which you can train your own models. So it's got both this mix of sort of built-in functionality from pre-trained models, and then functionality that you can use to train your own solutions on top of this, and also have rule-based solutions as well. So there's obviously a lot of functionality in this, and a lot of the work in this has been developed thinking about the API surface and backwards compatibility and these sorts of design choices, and trying to balance that against concerns like making it easy for users to onboard into the library, and how efficient the solution is, and how stable the underlying data structures are. And so this gives me this kind of perspective to think about from the library developer's point of view, like what should we really be trying to provide to people, and how should that be changing over time as people's workflows change. So and one of the observations that kind of comes with this is noticing that, hey, if we use ChatGPT, actually there's some things where we can get it to generate solutions, like say asking it to generate patterns for US addresses, and it knows the syntax for this, which is kind of nice. And then another thing that we do with our company, Explosion AI, has developed this annotation tool Prodigy, and this is another product that we've developed that has similar sort of concerns around generalizability and API surface and composable building blocks, etc. And we're also working on another solution, Prodigy Teams, which builds this out into more of a cloud solution. So, as I mentioned, in my own work, I've been using tools like ChatGPT or other AI solutions. So, out of interest, how many people here regularly ask questions of tools like ChatGPT as part of their development workflow? Yeah, all right. So a huge portion of you. How many people here still find that searching on Stack Overflow and things are reliably better, and you don't really use like ChatGPT? Okay, so that's interesting. I mean, obviously we probably all use like even if you use one, like programmers, you end up using everything, and we all have to be resourceful as we're working through our work and trying to solve our questions. But certainly I've found ChatGPT helpful for technologies which I'm a bit less expert in or onboarding in. So for instance, if I'm doing a bunch of infrastructure tasks with Terraform, I end up asking questions. Or if I'm trying to remember bash stuff, or these sorts of things, I'm finding it very helpful to go through that. And also just in addition to just getting like sort of syntax, finding out some things about conceptual model of how I should think about things, or like something about networks that I don't really know. Getting some explanation there in an interactive way, I'm finding is a lot better than web search for a lot of these things, especially now that in many ways web search I'm finding worse than it used to be. So this is one example of the the types of technologies that I'm talking about. And so I think of this as more like interactive documentation. It's the type of need that I would have fulfilled for myself before with web search via other things like Stack Overflow and things, or perhaps if I'm desperate, posting questions to discussion fora, what used to be IRC, mailing lists, etc. And then another type of feature are things like in-editor support. So we have tools like GitHub Copilot, where you're doing much more code generation, and this replaces things which used to be sort of scaffolding or code templating and stuff. So out of interest, how many people are regularly using GitHub Copilot or other like in-editor code generation as part of the daily workflow? Okay, so personally, I haven't adopted this as much. This comes to the types of work that I do, and then also just being a bit stuck in my ways and using Vim rather than VS Code and things. But I also feel that this type of feature is a little bit less advanced, a little bit less easily adopted than things like ChatGPT, but it's definitely coming, and I think it's something that is still significant to think about when we're thinking about how programming is changing. And then the next step along, rather than in-editor support, are things which are much more purely generator tools. So something that's a distinct tool that is supposed to look at your whole project and generate tests or something like this. So this is something which I also am not using, but I'm seeing this develop, and I think we can also expect that this type of technology will be coming along and helping as well. And then finally, it's also worth noting that the general IDE support and support that we have in developer tooling for Python is just getting better in general from things like typing, and the general ecosystem around this is much better than it used to be. And this I also see changing the considerations as a library developer and changing what it means to what I should focus on and what workflows I can expect users to have. So what are we thinking about with this, in terms of AI at least? Like what becomes more important, what becomes less important? So one of the things that I notice is backwards compatibility was always very important, but I see this now more than ever. When I'm using technologies that have had sort of evolutions of API over time, so things like Keras or TensorFlow, I'm finding it way harder to get answers from things like ChatGPT. And so I think that this is something where before, if you have these multiple versions, when you're searching, you're able to internally, read the thing and sort of keep this diff in your head of what's changed and what hasn't, and whether this discussion is about an area of the library or conceptual model that's changed and hasn't. Whereas if you're interacting with an assistant like ChatGPT, it's really not able to do that well. And so I think backwards compatibility, if we want to develop tools that help users engage or make use of things like large language models and generative AI, backwards compatibility will be more important than ever. So, it's just something which we've always known, but for LLMs, the problem's even more acute. So, another thing that I think is more important in this new, when we're looking at generative tools and designing libraries and programming to make LLMs more useful, I think using standard dependencies is actually more important than it used to be. So, and some of this actually is a thing which I find, a little bit hard to accept because it goes against how I've liked to program before. So in particular, there's always this trade-off about implementing your own solution for something that does a limited subset versus just importing a solution. And I've always been a programmer that leans a little bit more towards the implement and keep it simple and keep a sort of lower mental stack of, all right, I don't have to worry about that dependency. There's just this little bit of code that I've re-implemented, even if it's a subset of that functionality. I think that now LLMs actually changed that trade-off in a little bit towards using a general solution because it makes the code easier and more transparent for the LLM. So an example of this is in Spacey, we have a machine learning library of limited functionality that we use as part of the solution and that we developed ourselves. And now, okay, if we're making the same decision, the trade-off leans a bit more towards using something established like PyTorch instead, although there's still difficult trade-offs to be made around all of this. Another question around this is widening the scope of the Python standard library. So I think that if we're going to see that, all right, the ecosystem pressures are such that we have a few standard solutions that get more critical mass and there's more usage examples and there's just more user advantage to using these standard solutions, then does this push us towards moving more of those things into the standard library? So the standard library in Python is definitely, it's grown over time, and we've also pruned some things out of it. But things like having data classes as a standard library solution instead of an PyPy solution like Atlas, I think is really helpful for things like LLMs. And so the question is, in future, will we have something like, more of NumPy support in the core library and less in the ecosystem? So I think these will be things which we'll be debating as the Python community over time, because the advantage of having these sort of like more user choice and more options. Oh, I need. Hang on. All right, I'll just keep the mouse going. I think that if you don't have enough critical mass of documentation and discussion of a solution, then you really can't use the generative AI to help you. And so I think that pushes us more towards standardization. Another thing that I think is more important than it used to be is having a unified interface rather than different optional workflows that you can use. So an example of a tool that has lots of different optional workflows would be SQL Alchemy. There's lots of different ways that you can define your database coupling, and you kind of pick one channel and sort of work with that. Or TensorFlow has different layers of API. NumPy has this to some extent, and I think this type of thing with having these different workflows and different combinations that you have to know, all right, I'm using this style in the rest of my code and I want it this way, that I think makes it a lot harder for the generative AI solutions to work well. So it's clear why this ends up happening. Like, why do we end up with these parallel solutions? And I think that the core need that libraries try to address for this is having this sort of syntactic sugar of making things easier, but then the abstraction doesn't quite work for all use cases. And so you end up with these like multiple solutions developed over time. And in particular, you want to maintain some backwards compatibility for the old abstraction, and so you end up with these parallel things. So obviously, nobody sets out to design a library and says like, I'm going to have this situation. I'm going to have these different parallel things. But we see that actually the cost of this situation, I think, is higher now if we're programming for these new workflows rather than what it used to be. Because before it's like, all right, well, is it that bad? There's just different documentation, and yes, there's a little bit of fragmentation from code bases, but if it makes things easier, then maybe it's worth it. But now I do think it's more costly than it used to be. So one solution to this is actually maybe more often we should bite the bullet and say that some new workflow is actually under a new name and it's a new library. Because I think that does make it a lot easier for generative tools to see, okay, that's the thing that's being discussed, that's the usage pattern for this thing, even if it uses like the underlying primitives of this common library, if we call that something else, then I think that will make things easier rather than it all being SQL Alchemy code and having these sort of subtle naming problems of whether you're using the ORM style or not. All right. So what's the thing that's less important? Well, I think that something that's less important is having a lot of one-line solutions. So things being a super fast time to first result where okay, the user can go to the documentation, see copy paste a bit of code that does exactly what they want to do. That function is super short, or they're able to find a single function that serves their need, and that function wraps up all of its parameters and all of the steps that it needs, and that's the way that you use the library. So that that style of design gives you a really fast time to result, and I think that's very important to users because you can see a result and get to something initially very quickly, and that makes technologies easier to adopt. And this has been a competitive pressure that's guided us towards that type of solution, that type of API design. On the other hand, if we have a much smaller set of composable building blocks, and you put them together to to solve your problem, that's a bit harder to use at first, because you have to solve this little puzzle of how to assemble those building blocks to make to serve your need. So you're asking for a bit more investment from the user up front in exchange for having a smaller surface. And this has meant that, okay, what we've seen over time in the ecosystem is solutions which offer that time to first solution advantage, getting more adoption and, having users valuing that, and we end up with these APIs and libraries that have these larger solutions. Well, I'm hoping that actually generative AI can give us a solution to this, where we can have libraries that have a smaller API surface, and what users can do is say, okay, how do I do X with Y? And if that's like 5 lines of sort of setup and configuration and putting things together instead of one function call, then the generative AI solution can be the thing that provides that glue and is kind of like the colleague who already knows the technology super well and is able to just like put it out. And I think that this can actually be very helpful. So, yeah, as I said, it's clear why we've ended up with this, but I think we might have an advantageous situation. So this is what I'm suggesting, or I think can be the outcome of this. I think libraries could focus on providing the core data structures and routines. And I think that this is something which generative AI is still far away from doing, and it's where the programmers can really come in and put together those base systems and say, okay, this is how we want it to be, and then that also focuses on efficiency. This is not something that we're going to have generated for us anytime soon. That work needs to be done by us. And so if we focus on that as library developers, another advantage of this is that we end up with much better backwards compatibility, because we end up with a much smaller API surface, and it's this large API surface of having lots of different functions where we end up with these backwards incompatibilities, functions changing over time, and then these different layers of abstraction. Whereas if we ship less syntactic sugar and less of these immediate solutions, it's a lot easier to keep that stability. So yeah, if we have keep the API surface smaller, and then move more of the work into the sort of library developer sort of headspace of doing things like adding API IDE extensions, documentation examples, and ultimately using AI internally in the development team, and working on some development of the AI solutions alongside the library development. So here's a little example of what I mean by a flat API. If we have some function where this is a library and we want to get all verbs, well, one solution to this is having this sort of string. We give it the string. We say, okay, let's get all the verbs, and that's the sort of output that we have. So are, going, swimming, should, go, etc. And so, but there's a lot of options that we should have here. So do we want things like are and should? Well, that depends on what we're trying to do with the function. So we might have a flag that says, hey, let's filter those out. And then, okay, maybe we actually don't want these inflected forms. Maybe we want to trim it back to the base forms, especially if we're working in a language, most European languages. I imagine Lithuanian has much more inflectional complexity than English, and it's often really important to actually do this lemmatization step. Well, maybe we also want to trim duplicates. Should we include that in the function? And so we end up with all these flags growing over time. Instead, what we've done in Spacey, and what I think we can focus on more with this, is having, all right, there's one step where there's actually a step that's not shown here of initializing this NLP object, which loads statistical models, and then we call that as a function to get this doc object, and then functionality like, how do I get all the lemmas and unique this, etc. That's handled in code. So we, you just use Python sets. We use a dictionary comprehension, etc. And we try to give make sure that the user has the control flow so that they're able to interpose their own logic as they want, rather than having these trying to push everything into one function call. So ultimately, the question is, can we apply this beyond just library development? And as an industry, can we shrink product UI surface as well? So I think one of the implications of generative AI is actually that we can have the boundary between a programmer and a non-programmer can blur much more, and we can have much lower barrier of entry to interacting with programmatic interfaces. And I think that can be super powerful and super helpful to people who are interacting with tools professionally. So if we do something like interacting with a CRM, a customer relation manager, it's actually really difficult to avoid a lot of repetitive work of say, okay, I want to associate all of these people with this new name or change these people in some way. And so tools like this that are used by professionals every day end up with all of these different competing workflows and different ways of doing bulk actions and this sort of thing. And it's actually really hard to get that right. It's really hard to change it over time. And this ends up being where most of the complexity in developing these products ends up being. Whereas if we actually just had more programmatic interfaces, the developers would have to do much less guessing of what the users would need, and the users could have solutions which they can work with in much more detail and much closer to the metal and get what they need much more easily. So this is, I think, something that can be very powerful, and it's something that I hope we can have as part of our product landscape of much more emphasis on programmatic interfaces and having a wider variety of users able to use them. So overall, there's long been this ongoing struggle between the idea of like a simple tool and an easy tool. So we've always seen this, there's this famous talk like Simple and Easy by Rich Hickey, and I think this is something which as programmers we're used to thinking about. And we see that, okay, simple is this virtue, but we end up with easy for these competitive pressure reasons. And the story between this definitely isn't so straightforward, but I think that these tools ideally can help us get more simple because they relax the constraint around easy. So the hope here is that AI tooling makes simple easier. That's what I hope that we can get from this. The thing that I don't really have a solution for is how do we build the AI support for these new technologies? As we're developing a new technology, how do we make sure that we're able to develop a chat solution that users can use for it? And as a developer of a library, how do I improve the experience of using my library through that chat solution? Like how can I do that work of developing AI assistants? So that's something that I think we'll get from the ecosystem and different tools available, but I don't see a clear solution for this at the moment. So what I hope that we get to, like the good future, is that we get these high quality tools and using AI to help with the glue of putting them together. But what we could end up with, and what I worry about, is what if there is just this bias in language models where there's a huge advantage to incumbent technologies that existed before language models existed, when we all were discussing on Stack Overflow, we were all asking questions there, we were all writing blog posts, and so there's just this wealth of text that actually there's no replacement for. And so, what if we don't end up having a really good solution for developing these things for new technologies, and then we just are in this awkward situation where libraries and solutions which happen to exist before large language models are much easier to use with large language models. So that's what I hope we don't get. And I hope that we can solve that sort of problem. So, thanks.
Yep, thank you so much. Matthew, you have two questions from the audience.
Yep.
First one, it seems that LLMs struggle with information shift, library updates, backward compatibility, functionality versioning. Doesn't this mean that it's more of an LLM problem? Also, can we evaluate these qualities mentioned in the talk?
Yeah, so the first part of that, yes, obviously if you're looking at this from the LLM developer hat, you're saying, okay, I want to make this better. I want to relax the constraint that I'm imposing on, the library developer or author to keep things consistent. However, I don't think that that problem will ever be fully solved. And so as library developers, we'll still end up with this situation where, it's desirable for us to keep things a bit more consistent. So in the same way that you can say, well, it should be up to search engines to filter out information that is irrelevant because it's about old versions. And yet, when we were designing the Spacey documentation, we were super mindful of the fact that if you use certain docs templates, when you search for documentation, you're just going to end up with old documentation sites. And so it's So it's the same sort of consideration. You hope that search engines will be perfect when you present information on the web, but you keep in mind how they actually work and what's likely to happen, and you write your sites accordingly.
Thanks. Next question. AI tools help with programming workflows. What impact will it have?
There was a part of the previous question. There was kind of a second question tacked on there that I should have answered as well. What was it?
Also, how we can evaluate these qualities mentioned in the talk?
Yes, so that's a very good question that I haven't, that would need a whole other talk, and it's a question that's kind of ongoing over time. So this is part of this, what we need thing of these tools and like workflows for library developers to help them, internalize that AI linkage themselves within as part of the process.
Okay. Two Pauluses actually. Next Paulus. Question from Paulus as well. AI tools help with programming workflows. What impact will it have over the final products?
As in, okay, we're talking here about how it's changing the tools that we're using, but how does it actually change the final product? Well, I hope it's more about this offering more of these composable building blocks to the users as well, because I think that if we can get to this sort of blurring of the lines between end users and developers, I think that this will be helpful. Ines has a talk called "Let Them Write Code" that she delivered in, I think, India, at PyCon India, where she goes through this sort of this in more detail and talks about this blurring of the lines and how we can help people. So. Yeah.